Today's worksheet's called 3.3, number 3. Lots of 3's in there. Number 3. Lots of 3's in there. Extremely good number. And thankfully, it's mostly review today. Not all review, but mostly review. All right. If I asked you where ln of x was for a graph, would you just sketch me ln of x? Like, what the heck does that mean? Well, just make it into log base e. And if you weren't sure exactly what that means, you'd say log base 2.7 about. If you're not sure what that means, the log graph was the one that was like a tree that blew over, and that's how it becomes a log. Because if the tree gets blown over in the wind, now it's not a tree anymore, it's a log, right? Okay, so it's to look something like that. Raise your hand if you had that one right. Okay, good. Now, how steep that graph is really dependent upon exactly how good at doing these you are. I'm not that worried about how exactly steep that is, but that's a sketch. Now, if it was going to be on a graphing test, which is your next test, that's coming on Wednesday of next week. It's a graphing test. It'll be a lot like this, except I could not accept that answer. Why? 2 points and an asymptote. So the asymptote need to go down there, and then 2 points. Well, this is an easy one. Right there, that's an easy point to get. All right, and how do I get that point? I make an XY chart. So first I'm going to say y equals ln of x. Then I'm going to rewrite it like Mr. Server said to log base e of x. And then I'm going to make an XY chart, and then I'm going to have at least 2 points. One of the points, it's smart to use this is 0, because if the argument, no, I'm wrong, that is 1, sorry. Because if the argument is 1, if you won the argument, you still get nothing. You probably just tick off your friend. All right, so if you have a 1 here, you get a 0. Do you get how 1 comma 0 is on my graph? Now I got 1 out of the 2 points I have to have. That'll be an easy one. And then the last one is just pick something else. Now, there's a few logical things to pick. First one I'm going to do is I'm going to choose this to be the same as the base. I'm going to make that e. What? E? Well, that's just 2.7. Okay, so I'm going to say x is 2.7. You're allowed to, in my book, to round that to a 2.7. We know it's rounded. And then if these two are the same, what's the answer? 1. So 2.7 comma 1 over 2.7 up 1. And I might be up a little bit too high. So maybe I should have adjusted my sketch down like that. So there's the final answer, is the green one with the asymptote. Got 2 points, got an asymptote. It's good. All right, there's one more that's really handy if you're trying to pick points for this. I have one more good suggestion for you. Put in this spot right here where you're trying to figure out what should I put in for x, what are good things to pick. 1 over the base is a good thing to pick. Because if you pick 1 over e right here, okay, if I make x 1 over e, that means 1 over 2.7, which is a decimal. I get a nice answer. Why? Because this right here can be rewritten as e to the negative 1. So log base e of e to the negative 1. Do you get how that's a nice, easy answer? What is it? Some of you are not with me. Negative 1. That's another point. What is 1 over 2.7 though? Well, it's about like 1 over 3, isn't it? Pretty much like 1/3. Okay, so about 1/3. Do you think I'm really going to say, oh, you were off 0.03? No. So 1/3 comma negative 1. 1/3 means over not 1, but a little bit down 1. So there's a dot right there, and look at that. I was even in the right general area. Okay. That's 3 points. You don't have to have 3 points. But if you want another point to put in, you should use the base. You should use 1 over the base. And you should make this number 1. So try using that advice I just gave you, not ln, to do log base 3 of x. Make me 3 points and graph it. Since the next test coming is a graphing test, I want to practice that graphing. You got to have the asymptote. You got to have 2 points. But I just gave you an idea how you could make 3 points. Use the base. use 1 over the base, and then see what happens if you won the argument. I have found that to be one of those things that's true in life. If you end up arguing with somebody over something, there's almost never a person who really wins. You know, nobody ever comes in and says, "Oh, you won the argument." And the other person says, "Oh, you're so smart. Thanks for convincing me." No, they just get mad at you if you win. So if I won the argument, that's like putting a 1 in. I put a 1 right there. What's the answer? 0. You get nothing for that. So it's 0. And then another spot that would be good to check is the base itself. If I put in 3 in there, the base, that way these two are the same. And if I put in a 3, what's the answer? 1. And what's the third thing I suggested? 1 over the base. So in this spot right there, it would be smart to put in a 1 over 3, because that's 3 to the negative 1. And then you got log base 3 of 3 to the negative 1. See how nice that works out? The answer is negative 1. So if I use 1/3, it would be negative 1. Now think about this. Isn't this graph going to be insanely close to the last graph we just did? Why? Yeah, are all logs really, really close to each other? This was a 3 this time. What was it last time? 2.7. It's going to be pretty much the same graph. So hopefully it looked a lot alike. Something like that. Would that have been good enough to get full credit on the test? Nope, doesn't have the 2 points. Here's one of them off my graph. And here's another one, 3, 1. Yay, I got my 2 points. I got my asymptote. Could be good. Yes? It'll always be negative 1. Yep. You can bank on that one. So those are 3 easy points to get on logs. Use the base, win the argument or won the argument, and lastly, put in 1 over the base. All right, so how about if I have one that's all pre-written like this? Compare it to its parent. Which way did it go? Give me some stuff. Say it. Right, 3 and? Reflection over the what axis? Reflection over the x-axis. Good. Now I'm going to change it a little bit. Now tell me 1, 2, and 3. In what order should we do this? Right, 3 would start. Why? Wouldn't you normally do that first? Yes, but it's opposite normal order. So, right, 3 goes first. Then, this is not a stretch factor 2. It's a horizontal what? Shrink factor 1/2. And the last one is vertical reflect. That would work. Or reflection over the x-axis. Any questions on the order thing? All right. Let me give you one of these. See if you remember these. Log base 5 of 1 over 125. Don't say it, but figure out the answer and write it down. Hopefully right now you're thinking, how can I write that as 5 to a power? Because that's what you should be doing. Because if you could say it was log base 5 of 5 to the 3rd, for instance, which is not right, but if it was, then the answer would be 3. What is it actually? Negative 3. Because why? Because 5 to the 3rd is 125. The negative makes it 1 over 125. All right. Then we need to be good at fraction exponents. Write that as 2 to a fraction exponent. Like 2 to the 3/4, except it's not that. Two to a power. Why would you care? Because what if the problem said log base 2 of that? And now you want it to be 2 to a power so you can get the answer. Well, how about this? One baby step at a time. 2 to the what simple thing would fix part of my problem? 2 to the 3rd. 2 to the third kind of is getting there because now it's got an 8. So now we know it's a fraction exponent, so it's got to be 8 over something. What goes in the bottom? The roots. The roots go on the bottom, just like in plants. So that's a 3 on the bottom. What? It's just 2 to the 1? 2 to the 3 over 3? Just think about it. Isn't that the cube root of 8? And isn't the cube root of 8 equal to 2? Get how that works? So it's just log base 2 of 2. And then what? Therefore, what's the answer? 1. All right. How about this? Log base e of 1. Because if you have won the argument, you get nothing. Okay, good. Also known as e to the 0 power equals 1. And that's true, because anything to the 0 is 1. All right, let's move on. We have to learn how to solve some equations with logs today, and they're really not too rough. X equals log base 2 is 16. Do you agree it's an equation because it's got an x in it and it's got an equal sign? It's just an equation. So it's just the same exact thing we were just doing a second ago. It's just that you say x equals for an answer. So I'd change this to 2 to the what? 2 to the 4th, and therefore the answer is not just 4. X equals 4. I know that seems lame, but it's true when you solve an equation. You say what the variable is, equals. All right. So let's say the problem was this way. M equals ln x. Rewrite that as an exponent problem. What to the what equals what? Did you catch that this is log base e, and therefore it's e to the m equals x? Raise your hand if you had that right. Okay, good. Next, 10 log 7. If you know it, you already know the answer. If you don't know it, then think it through a little more thoroughly, write it out more carefully, and you can figure it out. Who's got the answer already? Raise your hand. 5 people, maybe. Okay. How about this? There's no base on that log, is there? Oh, but there is. But what is it? So therefore, do you remember this one where this and this are the same? The answer is 7. That ring a bell? How many of you actually knew that one? You had that one going. Okay, good. And how about this one? 5 ln 6. Does this answer come out nice? No. What one number could you change so that it would come out nice? Yes, sir. Change it to a what? Close. False. Also known as? Because that's rounded. E. I said, what number could we change in this problem so we'd get an easy answer? I changed one number to E. Well, E is a number. Just doesn't look like it. Do you get now that they both have E's? There's an E here. There's really an E right there also. E, the answer is 6 now. You're okay. I'm happy that you know that E and 5 are not the same thing. I was trying to show you a problem that wouldn't work out. I actually kind of thought some people would say, "Oh, the answer is 6," but you weren't dumb enough to do that. That was good. But then I was going to say, okay. But then I was going to say, well, what could I have made this problem so the answer would have been easy? That's what I tried to say. What could I have done to this problem? What could I have changed in this problem? And if I had made that an E instead of a 5, again, I know they're not equal, but if I had written the problem this way, then you could get a nice easy answer. Okay, that's all I'm trying to say. All right, let's try another one. Log. What's the answer?
0.
10. 0.
Would you agree there's a 10 there? You won the argument. The answer is always 0. Okay, how about this one? Ooh. No solution. Because you can't have negatives here. That's the exception to if there's a 1 here, the answer is always 0, unless the problem is illegal. This is not possible. You can't have negatives there. Breaks the law. You're under math arrest. Okay. Good. You learned enough to be awesome on this worksheet. I'm going to hand them out, and I'm going to do a couple together. A little break, and would you read me numero uno? Shh. Some people are still talking. Stop that. Just read me the problem. Number 1. ln 1 minus x. Oh, wait a minute. I did that wrong. 1 minus x. Okay. Plus 3 like that. Oh, awesome. Okay, now I'm supposed to probably just say what order to do things in or something like that. Let me read the top here. It says describe how to transform the parent graph into the graph of the given function. Sketch it. Identify any asymptotes. Then state, remember, any sketch needs asymptotes. Then state the domain and range of it, as well as use limit notation to describe the end behaviors. I'm going to allow you to skip the whole limit notation thing, but here's what we need. First of all, I want you to say what to do. Number 1, I would rewrite this puppy as negative x plus 1. It's way easier. Now, there's 3 things happening to it. Number 1, number 2, and number 3. Number 1, the first thing we should do, normally you do multiplies first, so you don't do that first. We would do that. This would be 1 left. Second thing you do on this one is a reflect horizontal, so it would be left right flip, so I could say a reflection over the y-axis. And number 3 thing is move it that, which is what? Up 3. Okay, good. So there's my list of things, how to translate it or how to transform it. Next it says sketch it. Okay, I can sketch that. Do you know generally asymptotes? Do you know generally where the ln function is? I hope you know it's log base e, and it's basically like that. That's a good enough sketch for that right now, because this is not a graphing test. If it was a graphing test, you'd have to have 2 points identified, but we are not going to require that on this worksheet. So that's good enough. Okay, I've sketched it. Now I got to move it, though. Which way do I move it? 1 to the left, so I go, then reflect it over the y. That's tricky for a lot of people. It goes like that. See how that's left-right flip? It's that way. Some people have a really hard time seeing those, but I'm going to draw it a little better. There. Okay, that's a left-right flip, and then it says move up 3. Oh. The asymptote has to move with the graph, though, and I didn't grab the asymptote and move it the whole time. So I'm going to get that asymptote out of there. So final answer is that green one. And now I would ask you, where has the asymptote? Where is your asymptote? Right there. So to start with, think about it this way. The asymptote was right here, was right on that line, right? And then I moved 1 to the left. That moved the asymptote over here. And then I did a flip, and that's what moved the asymptote over there. All right. Funny things your math teacher can say to you that sound naughty. Okay. Then last thing is state domain and range. Domain of this guy is from left to right. Well, how far left? Well, forever. So negative infinity. To how far right? It stops there at 1. Can't touch 1 either because there's asymptotes there. Range. How low can it go? Negative infinity. How high can it go? Positive infinity. Yes, otherwise known as all reals. Good. You do not have to do the limit notation to describe end behaviors. All right, so since the next test is a graphing test, I really want you to do all 4 of those because they're all the graphs. The next section is evaluating. We have done a lot of those already. It's good to have practice, but we don't quite need that much, so let's do just the evens in the evaluating section. You may skip the odd ones. Don't skip number 15, though. That's a solving. Now, that's the new thing for today. If we are doing number 14, that's a solve question. It says 2 to the x equals 8. I know you can just look at it in your head and do it, but I don't want you to. I want you to know how to write that as a log. So if it's in exponential form, I want you to write it as a log. If it's in a log, I want you to write it as an exponential. So do that rewriting thing. So this would be log base 2 of what? 8 is equal to x. And yes, it is true that it answers 3. But I want you to see the log first. And then say, okay, I can see that this must really be 2 to the 3rd right here. And therefore the answer is x equals 3. Just good practice to rewrite, because rewriting is the biggest part of logs. All right, so that's problem 14. Just do a little rewrite for 14, 15, and 16. 16 will test your ability to use fraction exponents. If you don't know how to write the thing on the right on number 16, you're probably going to have a hard time on this test because fraction exponents are big in this next test. You have to be able to rewrite 1 over the square root of e to the 5th. So 1 over the square root. I'll do something different that's similar. If it was like that, I would say 5 to the, there's 3 things going on here. There's the roots, and the roots go on the bottom. I keep on saying it. I hope you're remembering it. The squaring is the little 2. And the last thing is, how do I make this 1 over thing happen? A negative. That's how you would do something just like that. So this is a similar example for problem, to help you with problem 16. It's obviously different, but similar. All right. And I think you should do the rest of the worksheet because all of those are solving problems. I did do number 17 on the board previously, so that should be easy if you... It should be easy enough it's not even worth looking back at your notes because you can do it by hand just as easy. All right. That's all I have for the video for today, and thus you have the rest of the time